We are going to solve the problem maximum energy boost from two drinks. So we will follow this approach to solve this problem. First we will understand the question clearly, then we will see the top down plus memoization, then we will see the bottom up approach, then we will derive the time complexities. So for better understanding, please watch the video till the end. Now here you are given two integer arrays, energy drink A and energy drink B of same length n by a futuristic sports scientist, right? These arrays represents the energy boosts per hour provided by two different drinks A and B. So there is a one futuristic sports scientist, so he is giving different drinks for the sports people, right? You want to maximize your total energy boost by drinking one energy drink per hour. You can drink one energy drink per hour. However, if you want to switch from consuming one energy drink to the other, that means suppose you are drinking A drink, then you have B drink. Suppose you are drinking in A, right? For every hour you can drink one drink. Suppose you are switching it, right? If you are switching it, you need to wait for 1 hour to cleanize your system. So if you are switching to B, you need to wait, you need to skip the next one because you want to make your stomach empty and you want to cleanize your system. So you will wait it and you will take from here, this point, right? You won't get energy, that meaning that you won't get, so that means he is telling that you will be skip in that hour. We need to return the maximum total energy boost you can gain in the next n hours. So how much maximum you can gain in n hours? Note that you can start consuming either of the two drinks. Either you can start, like you can start with A or you can start with B. There is no restrictions for that. Now if you are saying this, what is telling that, suppose if you are drinking A energy drink, suppose you are drinking the 0th index, right? Then B, you should 0 index, 1 index, 2 index, so on. These are also 2, 3, so on. Suppose you are drinking this, then you can drink next drink. If you are going with the drink A, if you are switching it, that means you need to skip this, then you need to drink 2, right? You need to drink 2. So that means you have the probability to choose, right? I can select this or this. So that means, and you should select, and if you want the maximum total energy cost. So if you are seeing that whether I need to select this or this, if you have an options to select, then most probably it will be a DP problem. Should think like that. So if you have any options like I need to take this or this or this or this, if you are taking this, what will be my maximum? If you are taking this, what will be my maximum? So this is how you need to identify it is as a DP problem. Now let's understand the approach, like how exactly you can solve this. Now consider this is my A drink, and this is my B drink, right? And this is the flag that we are saying that I am starting with drink 0 or I am starting with drink 1. Consider I am starting with drink 0. So first A of 0 I will drink, plus. So now after drinking A of 0, if I want to drink the first drink, right? So my drink will be 0. That means I will be drinking the first drink and I can drink in the next hour. Now suppose you are switching it, then you need to cleanize your system, right? You need to clean your system. That means you need to skip this hour and you need to come here I plus 2 and you should drink B. So you want the maximum of both of this. Now consider we are drinking B of 0. I am starting with B of 0. So in B drink I am starting, then it will be max of I plus 1 comma 1. That means 1 means I am drinking B drink, so I can directly drink B2. Now if you want to drink this, right? If you want to drink this, then what I will do? Then I should go for I plus 2, right? I plus 2. So this is how it works. Either here I plus 1, here from here directly I will jump here. Directly I can drink A3, not A2, because we should clean our system during that hour. So this is how your dynamic approach will work. Now let's code it. Now let's see how exactly we can code this. It's simple. So after getting this approach, right, try to code by yourself. So if you are coding it by yourself, then you can think like how exactly the states works. So I am hoping that you have tried for a couple of minutes, and I hope that you have solved it. So if you haven't solved, you can watch the next part of the video. Now here we are going with answer equals to 1, solve 0, v1, v2, f 0. F is my type of drink, which type of drink I am drinking. I means it is my index. I means it is my index. Now type if f is equals to 0, what I will do is I will drink my first drink v1 of I plus max of I plus 1 comma 0, as we can see here, I plus 1 comma 0, right? Or else max of I plus 2 comma 1, I plus 2 comma 1. Same applies here. If I am starting with 0 drink, and if I am ended with 1 drink, like last drink which I have drink was the 0th drink or 1 drink, that what matters. So if it is B drink, right, if it is B drink, V2 of I plus max of, directly if I am going for A2, right, this one I plus 2 comma 0, here I plus 2 comma 0, I plus 1 comma 1. This is how you will get the maximum answer, right? You get the maximum. So if you run this, right, you will get TLA, because it will take exponential time complexity. So here you can think, can we optimize it further? They optimize it further? So think about the overlapping subproblems. If you are thinking, yes, you can think about overlapping subproblems, but coming to this, it's more important that how many states are changing. Now if you see here my index is changing, and my flag is changing, like which type of the drink I have drank last. This is what changing. So these two are changing. So what I will do is I will take int dp of, I will take this index total, how many we have, 10 power 5, right? So it will be 10 power 5 and it will be my 2, either it can be 0 comma 1. So this will be my dp states. So it's simple, memoizing it simple. So we have these two dp states, I comma f, so we will store that value I comma f. So if we are storing it, right, if we are getting that again, we are not computing it again, we are saying that I have already stored that value, so directly I will return it. So that's why if you are not equals to -1, directly we are returning it. So this is simple, right? As you know, if you are familiar with C++ or in any programming language, so we are just refilling the memset dp, we are refilling the memset. Now okay, this approach I got. So we have dealt with, we have understood the question, then we have top down plus memo. Let's see the bottom up approach. So how can you optimize this? How can you make bottom up? So now let's think now first scenario will be, my basic scenario will be, at the first, right, dp of 0 and 0 will be v1 of 0, right, and dp of 0 comma 1 will be v2 of 1, because in the first index A drink and I have B drink. So first you can choose either of this. I can start with either of this. Now I equals to 1, I less than n, I plus plus. So first I am taking this scenario. What I am telling, that dp of I of 0 equals to, directly I am adding v1 of I plus dp of I minus 1 0. Then dp of I1, v2 of I plus dp of I1. Directly I am adding the next element. Directly adding the next element. In the second scenario, what I am doing is, if my I minus 2 is greater than or equals to 0, what I am telling that when you are at this index, you are storing this. In this value. Now, or else I can store this value, right? I can store this value. That's why dp of I of 0 equals to max of the same thing, dp of I of 0 comma v1 of I, it will be the same, this value v1 of I, dp of I minus 2 comma 1, that means this is my 1, this is my 0, so this is my I minus 2 index and it will be 1. So this is how you will store that value, and finally you are going to return whether ending can be, it can end at 8th drink or it can end at bth drink. So which can be the maximum, you will return it. So same it will be. So it will be n into n, and we are using extra space, it will be n. We are using only n extra space, so it will be n. So this is also n, because only we are iterating n times, it will be n. So you can optimize this further, because you can see here, right, you are dependent only till I minus 2, right? So I minus 2 means total you required only 2 states, 0 comma 1. So you can optimize it further for space complexity. So I'm hoping that you will be doing that space optimization. So I hope that you have learned something new. If you learned something new from this video, please do like, and if you are new to the channel, please consider to subscribe. I have created a WhatsApp community, you can join there, and in the description I have given my LinkedIn profile, you can connect with me over there. I will see you in the next video. Till then, bye bye.